Okay, we're going to through part 3 of the Moll conversions. This one's going to be a little bit different. We're going to be kind of adding little stuff to it, making things a little bit more complex maybe not that difficult. So let's say I have SO2 and I have 238 grams of SO2. And I want to figure out how many atoms of oxygen we have in this thing. We are going to use the same processes, but this is kind of like a point where I have to go and add one more step to it. So we are going to have 2 steps. And we could do that as a start, just being aware we may have to do an additional step. But it still follows pattern. So we have grams of SO2 at the top. We're going to put the same unit to cancel it out, grams of SO2 at the bottom. And then, what needs to make an appearance? And of course, we have to go with the mole. Which one's the big one between the two? It is mole. We're going to cancel these out once we're done with getting the mass of SO2. Now we know S has a mass now of 32.1. And then I have 2 oxygens with a mass of 16.0, which is 32. Total mass added up is going to be 64.1 grams, which goes here. We got to keep going, so we know that we're going to have to cancel that one out, so we're going to go mole at the bottom. And we're going to go to something related to atoms. We're going to go molecules though, because we're not going to use the atoms for this. When we use the molecules here, it pertains to just one element. That's just kind of like the added part to this. So we have 1 mole here of SO2, and then we're going to convert to molecules of SO2. And then we're going to use our standard number, which is 6.02 times 10 to the 23rd molecules, which is over here. And SO2 is considered a molecule. Then we're going to go ahead and cancel these guys out. So now I'm in molecules of SO2. This is the thing that's going to be a little bit of a twist. Now we're going to put 1 molecule, because I keep moving to smaller things. Atoms are actually our smallest thing. So 1 molecule of SO2 has how many molecules of O? That is 2. So now I have 2 molecules of O. So if you notice, we easily put that one in. Calculator. I misplaced my calculator. Okay, so if we are going to calculate it out, again, you're going to have to make sure that it's kind of matching up. Now you're going to be multiplying these 3 numbers. So 238 times 6.02 exponent 23 times 2 divided by 64.1. So we got 4.47039 or whatever it is. I know if I'm looking here, I've got 3 numbers here. I want my answer to be in 3 numbers. So I'm going to remove the 0, and this is going to be atoms of O. So again, we just go with the flow. Maybe we want molecules, total molecules of the whole thing. That would be 3. Maybe we want molecules of S. That would be 1. So it is kind of flexible as far as what we are doing on this guy here. And it will change. No, so let's go ahead and do another one. We are actually going to use something with the density. So let's go ahead and I can find the density for something. Why don't we do copper? The density of copper is 8.96 grams per cubic centimeter. Usually these things are provided on the answers anyway. So it'll say if copper with a density of 8.96 grams per cubic centimeter, I'll move it over a little bit, is how many or what volume? Well, let's say I have 1,812 grams of copper, and they will ask, what is my volume? We just go with the flow because we know a volume can be in cubic centimeters. It actually would also be considered milliliters. We just do a little conversion chart here, and we go 1812 grams Cu, and then what we will do is we will actually use that conversion factor here. So that's 8.96 grams per cubic centimeter. We're going to go grams of Cu, but now we're going to use cubic centimeters because that's what my formula provides me. That is per 1 cubic centimeter, and my density is going to be 8.96, and this is where I'm going to put it. So again, you got to be flexible, but again, main objective, we follow the pattern. Let's see if I have an added number here. Let's go with the 3. We see we have 4 numbers here. We're flexible. We go to the 4th number here. We notice the 3 does nothing to the 2. We get rid of that. So we got 202 cubic centimeters, or 202.2 cubic centimeters, which is also 202.2 milliliters. Now let's go and add the stuff and actually add the mole into this. So I'm going to come over here and actually get another density. Let's go hydrogen. Has a density of 0.09 grams per cubic centimeter because it is very light. It's a gas. And let's say I'm going to go with my moles of hydrogen. By the way, hydrogen would be H2. I want to make sure that they have this in here correctly. Yeah, they just have H. Let's go HE. We're going to go 0.18. I don't want to add anything that's a little bit different. Again, a gas, pretty light. A little heavier than hydrogen. Okay, so let's say I have 25 moles of HE. And I want to figure out how many cubic centimeters this is. As long as I have a density, I can actually go ahead and solve this problem. And it really isn't that difficult. We are still going to use our knowledge that we have from before. We know that when I said we had moles, I said it was one step. If we follow pattern, what's going to go at the top? At the bottom. Well, we got moles of each HE, so we got the mole. Then you have to kind of be looking here. You'll say, this matches up with this, but first of all, I got to get it to grams in order to use that density. So I'm going to go moles of HE to grams of HE. The big one is the mole. The mass of HE is 4.0 or 4.016, but we'll go with the 4.0. Now we're going to go ahead and continue following pattern, and we're going to put the grams at the bottom. And then we are going to use our conversion factor here, which is cubic centimeters. Now from the previous one, we know that the cubic centimeters came out as 1, because it's grams per 1 cubic centimeter. And now I have to use my density, 0.18. A little part of this thing here, we do not reuse numbers. So once I use that 4.0, I can't use it again. We have to use this part here. So now we can just go ahead and calculate. We got 25 times 4, which is 100, divided by 0.18, which is 555. And again, I'm kind of taking a look at this part here. Now if you notice, I got two numbers. What's my second number here? That's a 5. What does a 5 do to that 5? It makes it a 6. We got 56. I got an open spot here. I'll just put a 0. That'll make it work, because these guys here at the end, if you take a look here, that means nothing. So adding it doesn't really add value to it. And we're going to go cubic centimeters. So again, you'll notice we can have something a little bit different, but all you have to do is just follow pattern. And what makes this how do you have an ability to go from moles to cubic centimeters? Well, we can go through the mole, because that's the way it always works. Let's go ahead and go to one a little bit larger as far as calculating it out. Let's say I have 7.8 times 10 to the 26 molecules of Ne. Now let's go ahead and get the density of it. I use my handy little conversions that I can find on the computer. And if I look at neon, I'm kind of looking for something that is on here. Let's go aluminum. That's going to be 2.7 for my density. So we're going to change this out to aluminum. It works. 2.7 grams per cubic centimeter. That's my density for aluminum. In order to get to this unit here, I'll draw my numbers here. Sometimes you may be unsure of how many steps it is, but again, I just follow pattern. I'll put MC for aluminum. Let's go ahead and follow pattern. What goes on the bottom? MC of aluminum. What is my next unit, or what hasn't made an appearance yet, which would be the mole of aluminum, which is the big one between these two. It is the mole. I got 6.02 times 10 to the 23rd molecules. Now I just keep moving. I got mole of Al here. What's going to cancel that out? mole of Al. Now I can move from moles to grams, which I have to do in order to get to this one here. So what I'm going to do is I'm going to go ahead and put my mass of Al here. And my mass of Al, I'm having brain lock here, 26.98, which would be 27.0 grams of Al. I keep moving. And of course, this is the big ones. Well, that's a mole. Now I just go ahead and put at the bottom grams of Al, since I'm following pattern and I want to cancel it out. And now I'll put the cubic centimeters at the top because that is where I'm going. My number again for cubic centimeters is 2.7 grams per 1 cubic centimeter. This is 1. And then I'm just going to put a 2.7 here. And then we have our calculation here. 7.8. And then I'm going to divide it by the bottom bar. Divided by 2.7. And I end up with 12956.8. That is a whole lot of space. I'm going to look at my numbers here. I'm only considering those two here. So I'm just going to use the two numbers. What's my second number? We got it here. What does the 9 do to the 2? Make it 3. So I got 1, 3. I have these open spots here. Might as well fill them in, but I have to stop at the decimal point because 12,956 rounds to 13,000. And it's going to be cubic centimeters. And again, we have our little hint here. Huge exponent here. My conversion factor for the bottom part has to be a huge exponent. Again, calculate this out. Make sure it comes out correct. This is the conversion going from molecules to cubic centimeters. So pretty much I can do it with anything. I can also do it with liters, but we will not do this at that time, at this time.